Namaste. In this video, I want to carry forward the ideas I discussed in part 1. So, in part 1, we saw the expression given by Aryabhata for the sum of the terms of an arithmetic progression and the generalization given by Aryabhata for 1 plus 2 plus 3 till n to the sum of the powers of 1, 2, 3. So, 1 square plus 2 square plus 3 square till n square and so on. And we saw his expressions for sum of the squares and sum of the cubes of the first n natural numbers. Okay, so Aryabhata had also given another generalization of 1 plus 2 plus 3 till n, which is known as the Chitighana. And this is given by the sum of the partial sums of 1, 2, 3 till n. And he has also given an expression for the Chitighana, which we will look at in this presentation. And we will also look at Narayana Pandita's generalization of the Chitighana to the concept called the Varasamkalita. And in part 3, we will look at the proof for the expression for the Varasamkalita, what it is, and in terms of with the help of the Meruprastara and ideas from combinatorics. But that's for part 3. So in here, let us look at Aryabhata's definition of the Chitighana. So the Chitighana is defined as the sum of the partial sums of the AP arithmetic progression 1, 2, 3 till n. So that means the first term is 1, the second term is now 1 plus 2, the third term is 1 plus 2 plus 3 and so on, and you can add it till 1 plus 2 plus 3 till n. So this is called the Chitighana, and you can see here on the right side I have showed a tetrahedron which represents the numbers, and it's very easy to see why it represents this Chitighana 1 plus 1 plus 2 plus 1 plus 2 plus 3, because if you look at the lowest layer of the tetrahedron, you see the red triangles. If you count the number of balls in that, it is 1 plus 2 plus 3 plus 4 plus 5. Then in the second one, in the blue layer, it is 1 plus 2 plus 3 plus 4, and 1 plus 2 plus 3 is the yellow one, and the green one is 1 plus 2, and the brown one on top is 1. So this is exactly the Chitighana for n equal to 5. So Chiti actually means a pile or a stack, and you can see why this word is used, Chitighana, because it's like you're stacking up layers of these triangles. Okay, and Aryabhata's expression for the Chitighana is given in verse 21 of the Ganita Pada of the Aryabhatiya. So here is the Sanskrit verse. Eko tara dyupa chiter gacchadyeko tara trisamvargaha shadbhaktaha sa Chitighanaha saika padaghano vimulova. So I will again skip the translation. You can pause it and look at the translation. And the expression given by the verse is given in this equation. So 1 plus 1 plus 2 plus 1 plus 2 plus 3 till 1 plus 2 plus 3 till n is n plus 1 n plus 2 over 6. You can prove this because you know the relation for sum of I going from 1 to n, and basically each term in this is such kind of a summation. So 1 plus 2 and 1 plus 2 plus 3. So you can apply this, and you then get basically and then when you evaluate this, you need to evaluate sum of I square and sum of I, and we know the expressions for this, and with this you get the expression for the Chitighana given by Aryabhata, n plus 1 n plus 2 over 6. A further generalization of the Chitighana, which can be extended to any order, was given by Narayana Pandita in his Ganita Kaumudi in the 14th century. So we can understand this as follows. This involves a certain level of abstraction, so maybe you may need to go through this part maybe once or twice to really get it. So if we define an superscript 1 as the sequence n, so basically 1, 2, 3, 4, 5, this n, if we define it this way, an1 as this sequence, if we define that, then further we define a second sequence an superscript 2, which is given by the partial sums of an1. So sum of ai1, I going from 1 to n, and this you will recognize it as just being 1 plus 2 plus 3 till n, and this is so sum of I going from 1 to n, and this has the familiar form n plus 1 over 2. Now you can go to the next level, an3, which is the sum of the partial sums of ai2, And when you do that, you will recognize this to be the Chitighana which Aryabhata had introduced, 1 plus 1 plus 2 plus 1 plus 2 plus 3, so on, and which has the expression as we just saw, n plus 1 n plus 2 over 6. Now you can, instead of defining an1 as n, you can actually define a lower level sequence an0 equal to 1, and then define an1 in terms of an0 by the similar idea of the partial sums. So it's easy to see that an1 is nothing but n, because ai0 being always 1, you sum the number 1 n times. So 1 plus 1 plus 1 n times gives you n. So an1 is n. So I just want to give the, once more the equations of this series in this form. So we have here an0, an1, an2, an3, an4, and like this you can go on for defining an5, an6, an7 till endlessly. And this generalization, this an4, an5, an6, etc. are called Varasamkalita by Narayana in the Ganita Kaumudi. And the question arises, we know what an0 is, an1 is, we know what an2 is, what an3 is in terms of n. The question arises, can we find out expressions for an4, then can we find out expressions for an5, and so on. And that is the part we will look at in the next section. Here I just want to just give a short glance into what an3 and an4 look like. So an3 is the normal Chitighana which of Aryabhata, and an4 would be the sum of the partial sums of this Chitighana an3. So it's like 1 plus 1 plus 1 plus 2 plus 1 plus 1 plus 2 plus 1 plus 2 plus 3, and so on. And you can see for an5 we will need to take the partial sums of an4, and therefore you would need one more bracket to express those properly. Alright, so are there expressions for an4, an5, an6 and so on? Well, the answer turns out to be surprisingly yes. And in fact, even though it sounds really complicated, because we saw that an3 required the sum of squares, an4 requires a sum of cubes, and so on, even though it sounds really, this is really complicated if you try to approach it that way. So, but the thing is, there is a very beautiful, easy and elegant solution if you approach this problem from the direction of prosody and combinatorics and the Meruprastara. So this is what we will look at in the third part of this presentation. Thank you.